All right. So, welcome to another wonderful, snowy, horrible, cold, windy. Did I mention cold day? So, what we're going to look at is kind of the hardware piece here this week. And so, what is involved in when we actually build out a system? So, this is changing even as we talk, because one of the things that's happening in a lot of businesses, we're moving this design components and what's actually in a lot of this, we're moving it out to the cloud. So a couple of things that are changing. We know that COVID has had a great impact and a lot of jobs are now remote. So we need to account for that. No longer do we need the technology in one location. A lot of times we need to put it in multiple locations. So that becomes a great change. Even before COVID, the idea of information systems as a service rather than you pay and build all your hardware up and you build all your software internally has really changed a lot of companies. And so I know, Chris, I'll pick on you because you talked about Square as a system. Well, that's not, you don't have to buy really any hardware. You've got a terminal that connects to them. And we're seeing that, especially in smaller businesses. It's kind of nice to be able to grab that abilities that a larger company has, but you're paying for a per usage charge. Now, at some point, you reach a limit of either what you can scale up to that way, or it becomes cheaper for us to implement it on our own equipment. So let's take email for instance. So the de facto email is Microsoft Exchange. If I'm purchasing Microsoft Exchange from somebody, so I need to get accounts and I'm purchasing a domain name and all those things, so it sounds like it's from me. The price, and I was looking here really quickly to see if we could find a price for one. I know some of the companies I've done business with, so if I go to put it on the right page would be helpful. So, hosted Microsoft Exchange. So, I don't have to build the server farm out. And in fact, with Exchange, it's not just one server. I have to have multiples even for a small account. So, this company says, all right, I have a couple of different models. So, it's either $8.49 a month or $19.99 a month. That includes compliance with a lot more security, and it allows you to email archive. Most businesses need the features here in the $20 a month price. So $240 a user for email a year. And some of you may go, well, I get my Gmail for free. But it's not quite the same thing. And in a corporate world, when we have email discovery issues, so if I had 100 employees, it can get fairly expensive. But just the licensing to implement something like Exchange, and I actually did this, helped with an organization just recently. What they ran into, so they have about 250 people needing email and Microsoft Outlook, or Microsoft Outlook and Word, PowerPoint, Excel. So they actually did a slightly different thing. They're doing a 365 account. They looked at upgrading all of their equipment plus the cost, and it was in the hundreds of thousands of dollar range to buy the license for server, for all the Exchange accounts and all the pieces and parts to really make it work. But they're still paying, and one of the things I did was made a presentation to the CEO was, what is this going to cost over like a 5-year period? And over a 5-year period, it was a little bit cheaper, but what it also did was took a lot of that hand holding off of the IT guy, because they're not Microsoft Exchange experts. So even though they're spending, I think the current price are about $8,500 a month for email and Microsoft Office. And that sounds like a lot of money, but it's cheaper than by the time you brought in your own servers and you started buying all the licenses for it. You're going to find that it's actually cheaper. So these are some of the models we were looking at. Now, this is the cheap low end, not equipped with anything. So you see a price like that and you go, well, that's not $8,000. But pretty quickly, if it'll let me do this, we'll see if our internet here is going to let us go there. So you think, well, yeah, but what I really need is I need a lot more pieces in there. So I think it's just going to show me the ones that are available right now. So typically for an Exchange server, and we'll actually use about 5 of those, we load it up with memory. We load it up. I don't see a configure piece here, so I think I can do it from base models and then do it that way. Probably not. Now, so by the time you actually build one of these, what we were pricing out was almost $20,000 without software. Holy cow. So we were at several tens of thousands of dollars in hardware cost. And then the software alone for Microsoft Exchange, the licensing will make your teeth holler. So sometimes it really is. So here's the base price from a company that I don't know if that's legitimate or not. And so depending on how many licenses you need, you can certainly get into the range of several hundred thousands of dollars in that. So for them, it was cheaper to spend $8,500 a month. And it gives them a little bit of flexibility. One of the items that's kind of nice is, say they buy another, and they're a medical facility, say they buy another hospital or something else we can transition or add, and we pay transactional costs. We don't have to then increase the server size and increase some of those pieces right away. So while it sounds expensive, so you have to have the base Exchange license for each server, and that pricing seemed really low, so I'm not sure that's not a scammy company, quite frankly, that I showed you. And then you actually pay for client access licenses, so every license has to be activated for each one. So that's part of the reason Hostway, when they're selling this for $8.49 or even $20, they're not making a ton of money on it. But the majority of that cash is actually going back to Microsoft. So there's a ton of different companies that do this kind of models, though. So sometimes it is a little cheaper to do it. I do want to look at, and there are some reasons sometimes we do put in pieces of our own hardware. So the server side, depending on what we're doing, there a lot of times is server equipment we need no matter what we're doing. So one of the things we're buying in this lab, so we've managed to get some funding. We're replacing all the computers in the lab. So those of you that saw it and noticed we had some, still 10-year-old machines in here, a couple of them. We're wiping those out. We're getting all new monitors. We're going to 4K monitors in here. So we still have to have that interface piece for the personnel. So whether it's laptops in here, desktops. And so we are actually buying a server for back here. Not a very expensive one. But we're buying a server that's going to do some items in here that we can't replicate without it. And there's not really a affordable software as a service alternative. And so I looked at Microsoft Azure, which I can actually do everything in their cloud. And the cost for me to do that, because I can get some volume licensing / educational licensing, makes it actually cheaper than pushing it out on the cloud. Kind of an odd duck. But we know that we're going to need desktops, laptops. In fact, right now, it is hard to buy laptops, business caliber laptops, because the demand is so high they run out. It is hard to get things. That demand has existed. We know we also have some supply chain issues. So some of the volunteer work I do, I'm working with a little ambulance squad trying to buy a ruggedized laptop. And we're having trouble finding one that's got the requirements they need, that's not $10,000 for a laptop, that also has the ability to use a LTE or a cellular card in it. So some of these things are really hard to come by. But let's take a look at what a typical company, and they use Amazon. We know Amazon is a giant behemoth at this point. But in Amazon, there's going to be thousands and thousands of servers back in their back end. In fact, Amazon is one of them that hosts. So Amazon, not just the merchandiser, but Amazon Web Services, AWS, is one of the largest hosting companies in the world, if not the largest. Things like Blackboard are actually hosted on Amazon Web Services. So those servers are virtual because it was cheaper for Blackboard to host them there than it was to purchase all their own equipment and create their own server farms and pay for all of those items. So you have people that are connecting with various devices, and I'm not really sure what that is supposed to be, maybe some kind of weird phone. So, but anyway, however you connect, that's how we're getting into that information, and we need more and more people to be able to connect remotely. So this is just an example of what a data center would look like versus what, those of you who've been in here, we have one rack, and it's got a few machines on it. In the administration building, we have several racks full of equipment, but it doesn't look like this. This is a high-performance data center. You're not going to get in their door very easily, hopefully. So if you look at a large data center and you want to store things there, oftentimes you can. There is a lot of those around. So it's not just the Amazons of the world. So a lot of times we use the word colo. So you might see something like, let's see if I can find a link to it. So here's one that's actually hosted in the building my wife works in Lincoln. So they've got a couple of them. So they actually, across the street, so downtown Lincoln, this is a smaller center, but they've got carriers that bring in, and you actually can rent space in there or computing equipment, either one. So she's in what's actually called the Sharp Annex, which I'm not sure they're going to talk about. They're across the street from it. They used to have pictures. Now maybe they're not wanting to do that necessarily, but they do all of these kinds of things. So if I want to rent a server, I can rent a server at $50 a month, or more servers for $400 a month, or a full rack where I put in my own servers. So the prices are actually kind of reasonable if you look at what's in there. So I was hoping that they would show some pictures of this, but, well, they do this one. So that's in the old Federal Reserve building in downtown Lincoln. They actually built the servers actually in the old vault to start with. And now they're in the Sharp building, which is next door, and they've continued to add on. That's a small network. Then you get to something like Google, and Google's data centers are much, much larger. So you can find pictures of some of the Google data centers around. There's actually, we're kind of in a weird area because we're one of the only areas that has actually two data centers in the same city. So there you can see a little difference. So there they're running liquid cooling. Those aren't electrical cables in most cases. Those are liquid cooling to try to keep everything cool. So Council Bluffs, if you don't know, is kind of a weird area where there's actually two giant Google data centers. So there's one actually in Council Bluffs, and then there's one slightly to the south of it that you can actually see going by the highway. Well, why do they build in Council Bluffs? Ability to connect. So, thank you, Watch. So there's a lot of fiber in that area, but more importantly, there's stable, cheap, and available power. So that's part of the reason that we look at those kinds of things. So our networks, we're looking for that internet backbone, and then inside we tend to make a smaller network. So that's certainly what we've done in here. That we've all learned about, the URLs and how we access pieces, hopefully. So we're not going to go into a great detail on that. But the software we do want to talk about a little bit. So as we're now trying to move this software where we can access it more universally, it also becomes a challenge for security. And how do I make my software available to users on either an app or some kind of a connection? And how do I also make it safe? Because as we know, if you look around every day, there's some kind of new cybersecurity hack going on. So Again, these are the different types of things. So back on the back end, we've got web servers, applications, our friend databases, and then typically on our devices, we've got some form of operating system. So we may have a Mac computer with Mac OS X. We may have a Windows PC with Windows 11 or 10 or whatever's out there. You may have a Linux device. You may have phones. You may have tablets that are running Chrome or Android or iOS for an Apple phone. And somehow I've got to get the information from here all the way back out to this phone, and I need to do it securely. So that's one of our biggest challenges that we have in there. So web-based applications are becoming more and more and more useful. Not just externally, but even internally to a lot of organizations. So rather than install a complete application on there, you point it to a web server that's hosted internally. Things like time clocks, most often they're pointing to a web server hosted internally. So, in my little bit of consulting with a couple police departments, we ran into, I don't want to put all of the criminal data records up in the cloud. That seems like a bad idea. But they're hosted on a web server, but it's only accessible internally. And so to actually access that web server, you type in the IP address, or it's got a link to it, and up comes a login window, and you have to log in. And they are enabling two-factor, so not only do they have to remember a username and a password, but they also need some kind of third-party, either something else you know, a device you own. And in this case, because we didn't trust cell phones and some other reasons, we ended up going with what's called a YubiKeys. So they have to have a YubiKey that's actually secured inside the building they have to go get to be able to get into this data. And that makes the State Patrol happy, and it makes the FBI happy, because they're able to access some of that data that way. So, a couple of other terms you're going to run into, and one of them that's kind of interesting, and I'm not sure where we settled on it, but we call all the different languages and rules protocols. So if you're a Star Wars nerd, 3CPO is actually called a protocol droid or a language droid. So if we have HTTP, Hypertext Transport Protocol, that means it's a common set of rules and a language that our websites work on. Well, we have a lot of those. FTP, File Transfer Protocol. So it's that common set of how we connect these things together because we're on a common set of rules. One of them you're going to see a lot, and it's the way we're doing a lot of this business, is VPNs. So VPNs allow us to create a private tunnel from a remote device back into our network. Most businesses that are now having remote workers, that's how you're conducting business. You're coming in on a virtual tunnel, so you may have a little icon on your desktop that says Cisco VPN or OpenVPN or whatever software they use. And when you connect through that way, even though you're connecting on your internet provider, so maybe you've got Quest or whatever it is you have as an internet provider, but it's encrypting everything and it's driving that traffic from your employer. So across this virtual tunnel. That way that data, when you're accessing their servers, isn't out there on the internet. It's encrypted. It's scrambled up and nobody can see that. So we've talked a lot about different types of pieces. So here we have those protocols again, and if we look at them, these are just some of them. Hypertext Markup Language, so that's the language behind a website, whether it's HTTP or HTTPS. XML is another one. So this says that's how we create tags. And then there's variations of that for business and different organizations. So you can have a business modeled XML. And XML really is just a tag in the front, a tag in the back. But the name of that tag, we describe what that data is, and so we can pass that data across. HTTP, so we talked about that, but what I didn't mention yet is this HTTPS. And so if I go almost anywhere on the internet, just make this over here. So I've got this little padlock up here on the left. Because this website to Peru State College Blackboard is actually an HTTPS. It's a secured connection. And if I click on this little padlock, I can see that, and it will tell me what I'm available to do, and I can look at site settings and all different kinds of pieces in there. But what that tells me is the data from this website is scrambled between the web server and my web client. Well, that's good. That's good. We want that in most cases. There are still websites that are not encrypted. So, notice here, this is a local radio station down there in Falls City, and I just use it as an example. Would I put in, hell, look, it says not secure. Would I put in my credit card information on a site that says it's not secure? I would hope not. So, it's another hurdle. Now, in this case, because all you're doing is browsing news or whatever it is, I'm going to argue that it's probably not always necessary. But when it pops up and says you can't connect to the site because it's not secure, what do your customers think? So sometimes we end up putting those on a server with a secure certificate just because of that. So there are some times we will do that. So as an overview, we need this idea of an architecture of our network. So technology, we will figure out what we need for technology, what we need for application software, and typically we will build out a fairly cohesive plan of what's going to go where. So when we got a little money and we knew we were going to for this computer lab, that's what we started to do. We sketched out what do we have for technology. So we recently managed to pick up some new TVs in here that are serving as monitors. We know that we have X number of data jacks. We know what we have for switches. Do we upgrade those? We know that my server from 2010 doesn't do what I want it to do. And quite frankly, it was far cheaper to replace it than try to upgrade a 12-year-old machine. We also are looking at what software we need. So obviously in this lab we need Microsoft Office, but what other software pieces do we need? And so we've got a fairly comprehensive list of what we need, how these things are interconnected, and hopefully when we get it all done, those things work as planned. Well, this is again kind of that new model, software as a service. So whether it's internal or external, we typically use this as external so that it's hosted somewhere remotely. So Blackboard is a software as a service for us. We don't own the server that Blackboard is on. We don't install, in a lot of cases, the software. We can modify our instance, but we don't own it. So what this allows us to do is come in and modify and use those services without actually owning a single piece of software. So one of the good ones I have, or one I like, so this is an interesting company. So I actually use this for when I decide to go bill a consulting client that I'm not doing for free. I use this product here called WaveX. Now, if I look at pricing, if all I'm doing is invoicing and accounting, it's free. I don't even get charged for it. What I do get charged for is if I process credit cards or I have employees. And what that does is they can then generate revenue from this, gives me control over my business, and it's all done. I don't own a piece of software. I log into this particular website. Now, depending on what I'm going to do, could I find cheaper credit card processors? Probably. But for what I do, the little bit I do, it actually works fairly well. And for smaller organizations, it might work fairly well. So it'll show you exactly what you can do, how they're making money. Now, notice that they've got some tax services including, they'll even file that. So one of the things that actually is interesting about this company is they got bought by H&R Block Software. So H&R Block actually owns these, so I don't know if they're going to stay free forever. But it's an alternative to QuickBooks Online. I could go to QuickBooks Online and do the same thing. I don't have to purchase QuickBooks. I can actually purchase a subscription. So in this case, they're not that horrible depending on what applications we need. So anywhere from $7 to $350 a year or more, depending on what you're going to do. And again, if you're going to do payroll, they charge for that and different pieces. So that's that idea of software as a service. We do the same thing. So Blackboard, I think, if I remember correctly, we pay about $80,000 to $100,000 a year to Blackboard to use their service. But again, we don't have to build a data center. We don't have to have that fiber capacity in. And because they're now hosted on Amazon Web Services, they're in multiple locations. They're not just in one data center. They're stored in several data centers. So even if we had an earthquake and it took out the California data center, or they had a hurricane and it took out a North Carolina data center, Blackboard still should be up and able to run. So this is really that idea. Most of this stuff is available within a browser. So there may be some things that are not available depending on a certain browser. So we know that Chrome seems to work better with Blackboard. There are issues with some of the other browsers. That's not a fault with Chrome because they're building to the standards we think that the web browsers are building to. But it's an evolving target, so we always have to worry about what's going to happen next. So there are some downsides to this. So one of those downsides is everything we have is out on the web. What happens if we don't have internet service? So I have actually seen in our state we're doing something similar where all the database for the motor vehicle records are stored in Lincoln. They actually use a form of this. If that data link gets cut to a county, you can't go register a car. Ah, darn, I got to save another $100 for tomorrow, right? So there are some downsides, and I want you to make aware of that, of what those are. So typically what we're going to do is something called a client server. So here we have clients, whether it's a computer or a printer or anything, they're hooked up with a server at some point in our network. So web server, web client. So we do have what they call this 3-layer model. That 3-layer model actually kind of works back with our network design and some of the things we might have seen, where we have this view layer. The view layer transfers that to the domain layer where it actually gets moved into the data layer and out to the server. So it's kind of a translation service if you want to think about it. So here might be a better way to look at it. So here's everything on our view layer, so our computers and everything can see it. The domain layer says, all right, we're gonna say how we're gonna format things and pass it back, or how are we gonna pass in this query back into our database server. So when we say 3-layer architecture, that's what we're looking at. So interactions, kind of a translations, and then here's where our data is actually laying at. So currently we're in some weird times because of worldwide events. So one of the things that we're working on is more and more things are that web-based, whether it's internal or external. So we're trying to reuse as much of these things as we can. It doesn't make sense to go out and completely recreate the wheel every time we decide to add a client or add some piece in there. So hopefully what we're doing is making our product stronger, better, more secure. And as we add additional components and items and features, then we're making those as interoperable as we can. So we get a little bigger out in the world, and this is kind of what we're looking at. So this might be a fairly large company. So if this is Peru, we have multiple internet service providers coming in, and we do. And they all come in together, and then we have our public web server. So peru.edu, public web server. We break everything here with some kind of a firewall, And actually, in our case, we actually have a firewall here also. But that firewall then keeps data that should stay back here, and doesn't allow things to come across. So it should block a lot of malware and different pieces. So in the back end, then we have things like our SAS server. We may have our own page, so bobcat.peru.edu. We may have other pieces hiding there. And then we may even have a lot of storage tucked away back here. So in our case, we actually do, because we store a lot of data here on campus. So that's kind of a layout of a fairly typical corporation. If we look at it this way, now we're looking at how we connect all the applications and the databases together. So here we've got different subsystems. We know that in most cases we're using SQL, and that's fairly common for a lot of different products. And that SQL will change just a little bit depending on what version it is, because every manufacturer has decided just a little bit differently to how they're going to implement that. So when I look at something, I want to figure out what are they using for operating systems. So if I go in and I see that they have servers running, but they're running server 2003, well, that tells me a lot about that company and where they're at in their structure. So what tools do they have? What kind of interaction? How are things connecting? Are there security protocols? You can actually run a business wide open, and it's not necessarily the way we want to do that. So we need to kind of think about what's going on. How is data moving in and out? Is it the most secure model we're using right now? In a lot of cases, what happens, though, we build this system, and we run into at some point an issue, or we try to figure out how to do something, and we leave a lot of security pieces laying on the floor because we needed to get it up and running. And we've never went back in and fixed those. So I always want to call it Rocky Mountain, but it's Ridgeline environment. So here's kind of what they have currently. So here's our workstations, here's our credit verification, a firewall to keep people out that are in the web servers from getting any closer to our internal network, VPNs to, in this case, retail stores, and in this case also to our supply chain, wherever that's at. So a warehouse that the trucks are arriving at, for example. And notice here they've got 100 meg per second LANs. Here they have a gigabit, they say, because they've got more data coming in and out there. But what we know, and I think this is actually kind of prophetic, more mobile devices and apps. Well, when I look at how many people enroll, we have almost half of our students enrolling at Peru on a mobile device at this point. Great. Well, we know we're going to have more mobile devices, more web apps. Well, now we've also got links into social networking, Facebook, Instagram, those kinds of things. Oh, and security. And we're gonna see security over and over and over again because it's a huge issue for most businesses. And they've decided that they're going to host some of this business externally. So this is a proposed plan for an upgrade. Oh. So now it looks a little different. So, distribution, employees, so they've still got all kinds of devices, but they've got a gateway in, and now we've upgraded those to at least a gigabit. Gigabit. Customer service, they can also get to via the internet in some model. So, here's our gateway for manufacturing, retail stores. Now we're all connecting to a 40 gigabit connection. So we've got a much bigger connection. We've got all these servers down here, social network servers, because maybe we're trying to really use social media, applications, content management. So some of these, notice now, are external. We've said, I don't want the web server to be something that we have to deal with. Maybe we put some of the database server external to our network, because it's cheaper for us to rent that service by transaction than it is for us to build it. So, application pieces, and so So here we've changed this a little bit because now we have all these view layers. Those are all served out, and it makes our life easier. We're still connecting with SQL, but now a lot of this is handled external to our entire network. Here's where we have to be careful, though. Where is this data? Who's responsible for it? So in this case, one of the things we need to do is the trade show has a copy of the inventory. They can't change it except for a nightly update. So they'll send in what they've added updates. The inventory master, so hopefully it gets imported and updated on a regular basis. Our supply chain also needs access to that inventory, but they need it a little more frequently. So they need an hourly update, not a daily update. So we need to think about who can use our data, who can access it, who can delete it accidentally. So there's a lot of pieces to this idea of designing our system. So when I describe a system, external, internal, technology, why do things work the way they do? And then I start looking at what are ways to improve them. And we run into sometimes some issues when you look at that. Because what we're going to do when we change from Model A to Model B, there's some money involved in this. And a lot of companies, especially smaller ones, well, this is the way it's always worked. We don't need to improve it. And so sometimes you need to take a look at how those resources are working. So if you have an employee that's sitting there 20 minutes to wait on that server to spool up so that they can change one inventory item, that's not very cost effective. And so we can use those metrics, but it's how you present them. And so one of the things I will leave you with here is that people at the C level, CEO, CFO, they don't have a lot of time. They've got a lot of responsibilities. They're typically spread out, and they have an important golf game every day on Wednesday, right? So what they like is executive summaries and charts. If I can make a colorful chart that illustrates my point and shows the advantage, sometimes that is the way that we sell an idea rather than simply saying, hey, it's going to save us money. Businesses run on money. How do I prove that it's a better model? What is my return on my investment? So if there's not a return on the investment, businesses are not probably going to be willing to spend that upgrade. The one that is very hard to sell is security upgrade. Because unless something goes wrong, it's hard to sell that as a piece. But when it goes wrong, then certainly you can sell that idea. Because that suddenly becomes far more important when they're losing $1 million a day because their website's offline. So, and we see those a lot. So this just gives us a way we can look at that network. So these are kind of that pie in the sky. This certainly doesn't describe every device, but it gives us that overall architecture of how we're connecting. And most people could look at this and say, all right, I see how we're connecting then to various people in different places. So here's our customers coming in, and oh yeah, they're going to hit this firewall before they can do anything, right? So that's kind of how we can look at this kind of an outcome. All right, so a couple of quick things. So this week I took out, there's one assignment, and then there is a quiz for this week. There is a discussion board for this week. So talking about software as a service, so you're going to look at that. Remember that we have next week is a regular class, and then we actually take a week off for spring break. So I will try to put some dates in there so we can all keep track of that. All right. And I will also be sending out links, so hopefully we can do Zoom chats together.